Yeah, welcome. So the topic we are going to discuss in this lecture is we'll be moving to a fresh topic which is searching and sorting techniques. So in today's class we shall discuss about the basic searching techniques which is sequential search and binary search. Okay. So coming to sequential search, we might have used several times in several programs, but let us formally discuss sequential search here. Okay. So the idea is simple. Given a list of numbers, we have to identify whether a particular number is in the list or not. So from the beginning of the list, we have to search. Say if you want to identify x, whether x is in the list or not. Then starting from the first element, take the first element, compare with x. Is it matching? No. Then move to the next element. Is it matching? No. Then move to the next element. Like that, you keep comparing until you find the value x. If x is equal to 18, say in our case if x is 18, then keep comparing. Next element is 42 is equal to 18, no. Is 94 is equal to 18, no. Is 18 is equal to 18, yes. Then stop the process, because already we have found. Now we can break. Then you come out of the loop and say that yes, that particular value is in the list. Otherwise keep searching. Say we want to search something called as 28, which is not in the list. Is 18 is equal to 28? No. Next. Is 6 is equal to 28? No. Then go to next. Is 67 is equal to 28? No. Is there is any other element? No. So stop the process. Now we should come out and say that the element that you are searching is not in the list. Okay. So this is how the basic sequential search works. So when you search an element which is not in the list, then it needs n comparisons. That is, if there are n elements in the list or in the array, then all the n elements should be searched. Then only we can say that that particular element is not in the list. So for an unsuccessful search, the number of comparisons to be done is n. Okay. Whereas for a successful search, the average number of comparisons that we will be doing is n plus 1 by 2. You may ask how it is n plus 1 by 2. So that is given by this equation, sigma I is equal to 0 to n minus 1, I plus 1 by n. Okay. So here you can see it is going from 0 to n minus 1, because normally our array location starts with 0 and it ends with n minus 1. That is, if your array is going to hold 10 elements, then it will start with 0 and it will end with 9. Okay. If it is going to hold 100 elements, then it will start with 0 and it will end with 99. Okay. So in that context, here it starts with 0 and ends with n minus 1. Okay. But even though if the element is available in the 0th location, that doesn't mean that you are performing 0 search. Then also we are performing 1 search. Okay. So if the searched element is available in 0th location, then we are performing how many search? 1 search. So that it is I plus 1 by n. Out of n elements, if the element I am searching is in the 0th location, then I am performing how many search? 1 search. So if I is 0, it is 0 plus 1. That is, out of n elements we are performing 1 search. So that is 1 by n. Okay. If the searched element is in the first location, then we are going to perform how many compare operations? 1 and 2. Okay. So that is so that it is I plus 1. Okay. If that is, if the searched element is in first location, then 1 plus 1 it is 2. Are you getting? So if the searched element is in the first location, then we are going to perform 2 comparisons, so on and so forth. If the searched element is in the second location, then we are going to perform 3 comparisons out of n elements. Okay. If the searched element is in n minus 1th location, that is the last location, then we are going to perform how many comparison? N minus 1 plus 1, that is n comparisons. Okay. That is n minus 1 plus, that is n comparisons out of n elements. Okay. So this is how this equation is formed. If you expand, you will get this. For example, if you expand this equation, so what you will get? There is nothing like 0 by n, because 0 by, when I is 0, it is 1 by n. Okay, then it is, when I is 2 it is 2 by n. It is a summation of all these things, right? So when I is 0 it is 1 by n, plus when I is 1 it is 2 by n, when I is 3 it is 3 by n. Okay, so on and so forth. When I is 4 it is 4 by n, so on and so forth up to what? When I is n it is what? When I is n it is n by n. When I is n it is n by n. Okay, yeah, because sorry, when I is n minus 1, when I is n minus 1, the last is n minus 1. When I is n minus 1 it is n by n, because it is n minus 1 plus 1. Okay, so this 1 it will cancel out, so n comparisons out of n elements. Okay, now this equation can be written something like this, right? N is a common denominator, so we can write this as 1 plus 2 plus 3 plus so on and so forth up to n. Okay, now what is the sum of first n numbers? See, this is you see, this is, here we are number of comparisons we are saying, this is not numbers. Okay, when the searched element is in the first location, 0th location, 1 comparison, first location 2 comparison, second location 3 comparison, third location 4 comparisons, like that. N minus 1th location n comparisons. Okay, so at the top now we are getting 1 plus 2 plus 3 up to n. The sum of n elements can be written as what? There is an equation which is called as n into n plus 1 by 2. This is a standard formula or equation. If you want to find the sum of first n natural numbers, you can directly apply this formula. You can check out. Okay, n into n plus 1 by 2. Okay, so this second part, I mean the numerator part, we can replace with this n into n plus 1 by 2 and divided by n. So divided by n means this n and this n can be cancelled. So the result is what? N plus 1 by 2. N plus 1 by 2. Okay, so this is how we got this n plus 1 by 2. Okay, so if it is a successful comparison, then if it is a successful search, then at an average we need this many comparisons, n plus 1 by 2. Okay, if n is 10, if there are 10 elements in the array, then we need 11 by 2 comparisons, that is approximately 5.5 comparisons. Okay, so that's what this says. Okay, fine. Now coming to the logic of the sequential search, it is very simple. So what is that? So some number we want to search. So say let it be search number. It is available in the variable search number. This is the one which we want to search. Okay, so now what we are doing, for I is equal to 0, search an array list that has n numbers, return I is the index. Okay, if the number is present. Okay, if list of I is equal to search num, return minus 1 if search num is not in the list. Okay, right? So that is what we are doing, right? So here we are doing something like list of n is equal to search num. I mean, see, n is what? N is number of elements. So your number of elements, if there are 10 elements, then the array contains only 0 to 9 locations. Okay, so 10th location is not part of the one which we are searching. Okay, so here in the last location, in the 10th location, they are storing the number that will be searched. Instead you can keep it in some other variable also. Okay, and this is a for loop for I is equal to 0 while list of I, for I is equal to 0 while list of I not equal to search num. Okay, for I is equal to 0 while list of I not equal to search num, I plus plus. If at any point of time, if list of I becomes equal to search num, then it will come out. Okay, after coming out, what we are checking? We are checking whether I is less than n or not. Okay, why we are checking like this? Because anyway we are storing in the 10th location. Say for example, the element 5 you want to search, but the array actual element to be searched is in 0 to 9th location. Okay, 5 you want to search, that will be in the 10th location, but 10th location is not in part of our search limit. Okay, we are going to search only from 0 to 9, right? So from 0 to 9 we are going to search, and we are going to check whether 5 is somewhere there or not. If 5 is somewhere there, it will, in between it will, the loop will stop and it will come out. So after coming out, we check whether I is less than n. If I is less than n, then we return that particular I, because that is the location where this element that we are searching is stored. Is it clear? Suppose if I is not less than n, then we return -1, which means that the element that we are searching is not in the list. Okay. So this is about sequential search. We will discuss the code. Okay. Next, coming to binary search. See, binary search is very similar to what we have discussed in binary search tree. Binary search is applicable only for sorted list. Binary search is applicable only for sorted list. So before that, the list should be sorted. So assume the list contains these elements 10, 20, 30, 40, okay, and 50, okay. Okay, say that list contains this many elements. Now the list contains five elements. Starting index is 0, ending index is 5. Okay, starting index is 0, ending index is 5. So we maintain 2 pointers, start, end, or we can call it as left, right. Here it is called as left, right. So left is 0 initially, right is 5. Okay. Now we will calculate something called as middle. Middle equal to left plus right by 2. So what will be middle? 0 plus 5 is 5. 5 by 2 is what? 2.5. So 2.5, you just perform integer division. So when you perform integer division, you will get 2. Okay. So what is that? M is 2. M is 2. Okay. So M is 2 means you have to go to the second location and you have to search. This is the array. It contains 0, 1, 2, 3, 4. Okay. Yeah. Sorry. The last location is 4. The last end location is not 5, it is 4. Okay. So if it is 4, then what is middle? 0 plus 4 by 2, again it is 2 only. Okay. So middle is 2. Now you go to the second location of the array and see what is the element. And before that, you have to ask the user which element you want to search. Say the element that to be searched is 10. 10 is the one we want to search. Okay. Now, or let us assume 50. 50 is the one which is to be searched. First location. Okay. Now the algorithm, what it will do in the sense, it will check whether this element, the array content should be sorted. That you have to keep in mind. Okay. Whether the element at this location is greater than the element that is to be searched, or is it less than the element that is to be searched. Okay. If it is great, now in this case it is greater than. The element to be searched is greater than the element, greater than the current position. Okay. It means that the element to be searched is in the right of this. Okay. There is no point in going left. Okay. So it will update L. It will update L such a way that L will become M plus 1. Because we know that up to M location that value is not there. So L will be updated to M plus 1. What is M? 2. 2 plus 1 is 3. So L will become 3 in the next round. Okay. Now once again we calculate middle, left plus right by 2. 4 plus 3 is 7. 7 by 2 is what? 7 by 2 is 3.5. So let us assume it is 3. Okay, integer division, let us see 3. So middle is 3. Now we go to the third location and see, is this element is equal to the element to be searched? No. Is it greater than? Yes. So it means that it means that the value is in the right, not in the left. So once again this will be updated. So once again left will become middle plus 1. So middle is previously 3, so left will become 4. Okay. 4. Right is right, we are not updating. Okay. So then now once again calculate middle. Left plus right by 2. 4 plus 4, 8. 8 by 2 is 4. So middle becomes 4. Okay. Now you go and check the fourth location. Is this is the element to be searched? Yes. Then come out. So now we have found 50 in just 3 comparisons. If you apply sequential search, you would have done 5 comparisons. Okay. Right. If the size of the array is 100, now the number of comparisons will be reduced drastically. Are you getting? If it is 100, then to find 50, when you use sequential comparison, you have to perform 100 comparisons. But that will not be the case with binary search. Okay, first it will go to 50. Are you getting? Then it will perform 51 plus 100 by 2. Okay, 51 plus 100 is what? 151 by 2 means it will check in almost 75 or 76 location. Okay, then again it is not there, so 76 plus 100 by 2, 176 by 2, in the sense how much? 175 by 2, it is somewhere near 80 or somewhere, that locations it will search, 78 or 79. Okay, again it is not there, it will like that, it will keep increment and the number of comparisons will be reduced. Okay, so this is how the binary search works. For example, if you want to search 10, let us assume we want to search 10. Okay, if you start from the beginning, say now we want to search 10. In that case, how it works, let us see. Say the element to be searched is 10. Okay, now L is 0, that is left is 0, right is 4. Okay, middle is what? 4 by 2 is 2, so middle is 2. Okay, now we compare the second element. Is it equal to the element to be searched? No. Is it the second element is greater than the element to be searched? It means that the element to be searched is to the left of the list, not to the right. Now we have to update the right pointer, so the right pointer should become middle minus 1. So now R will become what? Middle minus 1, R will become 1. Okay, after updating R, again we update M. So 1 by 2. Okay, 0 plus 1 by 2 is 0.5, which is 0. So M will become 0. Okay, so the next round it will go and directly check 0. 0th location is 10. Is it equal to 10? Yes. So it will search and it will come out. Okay, so that's the logic. That is the logic. So we set initially left as 0, right as n minus 1, middle is something like this, while left is less than or equal to right. Okay, suppose sometimes the element may not be there. In that case, how long we should compare? As long as left is less than or equal to right. Okay, for example, say you want to find 2, which is not in the list. Okay, so in the second comparison, it will compare with 10. Is 10 is equal to 0? No, it is not. Okay, so what is our right? Right is 0. Okay, so now right is 1. Okay, so now in the next round, what will become? Right will become middle minus 1. So right will become 0. 1 minus 1 is what? 0. 1 minus 1 is 0. Okay, again if you compare left plus right by 2, 0 by 0, left by 0 by 2 is 0. Okay, second time also it is 0. I mean middle is 0. Okay, right? Sorry, middle is 0. Middle is 0. Previous round middle is 0. Previous round middle is 0. Okay, so now if instead of 10, if you want to find 2, it is not matching. Okay, then right should, then it means it is to the left of the list. So right should be updated. Right should become, will become what? M minus 1. M is already 0. 0 minus 1, it will become minus 1. So minus 1 is less than left. Okay, L is, so as long as L is less than or equal to right, it will continue. Otherwise it will come out. Okay, so this is also one of the way to find whether the number is in the list or not. Okay, so while left less than or equal to right, here we check, we calculate middle is equal to left plus right by 2. Okay, then we compare. Switch, you have to compare. We can compare with if. Okay, here they are writing some separate function. So switch compare, while switch compare list of middle dot key. So it is not a direct array, they are using as a structure. Middle dot key comma search num, is both are same or not. Okay, so if it is, what do you call, if it is same, it will return 0. This is a compare is a function which is going to compare the middle element with the element to be searched. If both are same, it will return 0. If it returns 0, we are returning middle. That is, the element is available in the middle location. Okay, right? If what you call, if the number is greater than, if the number is greater than the number that you are searching, okay, if the middle value is greater than the number that you are searching, then it will return 1. Okay, if the middle number, if the middle value is greater than the number that you are searching, then it will return 1. In that case we are making right is equal to middle minus 1. Okay, if the middle, if the value at the middle location is less than the number that you are searching, uh, then it will return minus 1. In that case we are making left is equal to middle plus 1. Okay, right? So this is the logic. Okay, uh, so this break, I don't think this break will come here. This break should come here. Okay, if it is case 0 only, we need to break, right? Yeah, otherwise this break is okay, it is correct, because see, switch case always it should end with a break. Okay, so it is just for the breaking the switch case, nothing else. Every case should end with a break statement other than the last case. Okay, so that it is ending with a break. Here case 0 is already a return, so there is no need for break, and for the last case you need not give a break statement. Okay, so here if you find the complexity of this algorithm, it is order of log n to the base 2. Okay, which is similar to the binary search tree. So here is the binary search tree. So in binary search tree also we do the same thing, right? If the element to be searched is less than this, then go to the left subtree. If it is greater than, then go to the right subtree. And if you traverse the binary search tree in order style, you will get the values in the ascending order, right? Okay, fine. Now let us quickly see the implementation of this. So first let us discuss about the linear search. So here is the code. We are declaring, including a header file stdio.h, and we are creating an array A of size 100. This is the main function. We are declaring some variables. We are asking the user enter the number of elements in the list. We are reading it in n, and we are asking the user to enter the elements one by one for the list or the array, and that we are reading in the array using a for loop. Then we are asking the user to enter the element to be searched, and that is read in a variable search. Search is already declared here at the top. It's integer search initially, and also there is a variable found. Initially we set found as -1, which means whatever the value we want to search, that we are assuming it is not in the list, so it is set as -1. Okay, then we go through the list one by one. For I is equal to 0, I less than n, I plus plus. If a of I is equal to search, if a of I is equal to search, if I element of the array is equal to the element to be searched, then what we do, found is equal to I. Okay, then we say that okay, I have found the element in ith location, and we break. Okay, otherwise if suppose if the element is not at all in this array, then it will the control will never come into the if, and found will never change. Okay, found will be as it is -1. So after coming out of this for loop, so this for loop can come naturally out. That is, if the for loop will execute n times, and then it will come out if the number is not in the list. Otherwise the for loop will break in the middle and it will come out. So here we are checking if found is equal to -1, then it means that the number is not in the list. So we say that the element is not in the list. Otherwise we say that the element is in the list in so and so location. Okay, let me execute it. So compile, this is binary search. Linear search dot slash linear. Number of elements 10. Elements say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. Enter the element to be searched, say 60. Okay, so the element is present in 5th location, because 0, 1, 2, 3, 4, 5. Okay, right. Now let us discuss the code for binary search. Yeah, nano, this one binary.c. So as usual, here we are declaring an array of size 100, and n also I am declaring as global variable n, the number of elements. This is a sort function. This is a binary sort function which is used to sort the contents of the array in ascending order. Okay, so this is a normal binary sort. We will be discussing binary sort separately, so at that time let us discuss this in detail. So basically it takes every element, the first element, and compares with all the other elements, and checks if it is less than, if the first element is greater than any of the other elements, then it will swap. Okay, so at the end of the first iteration, the smallest element will come to the first location. At the end of the second iteration, the second smallest element will come to the second location, so on and so forth. That is how this function works. Again, we are declaring all the variables required. So search, start and end. Instead of left and right, I am calling it as start and end and mid. We are asking the user enter the number of elements in the list, that is read in n, and we are asking the user to enter the elements, that is read in the array. Now the user can enter the elements in any order, or if the user can also enter the elements in sorted order. Suppose if it is not in the sorted order, we call the sort function, which will ensure that the elements will be sorted. Because in for binary search, the element should be in a sorted order. Then only binary search will work, otherwise it won't work. Then we are asking the user to enter the element to be searched, that is read in the variable search, and initially we are setting start as 0, end as n minus 1, and initially we are setting mid is equal to start plus end by 2. Okay, and initially we are assuming found as minus 1. Then, as we have discussed, while start less than or equal to end, what we do, we check whether the mid element is equal to the element to be searched. If that is the one we are searching, then we say that found is equal to mid and break. Okay. Otherwise, else if the mid element is less than the element to be searched, if whatever the mid element, if it is less than the element to be searched, then it means that whatever we want, that is in the right end of the array, that is in the other end, then start should be updated. Then we make start is equal to mid plus 1. If these two conditions were not satisfied, then it means that whatever the element we want to found, that is in the left end of, okay, that means that the mid element is greater than the element to be searched, that is the element to be searched is smaller. So in that case, end should be updated, so end becomes mid minus 1. Then once again we calculate mid is equal to start plus end by 2. Again it will go to the beginning and it will check whether start less than or equal to end and compares, right? So finally it will come out when start becomes less than, when start becomes less than end, or if it founds an element. Okay, so if it founds an element and then it comes out, then found will not be minus 1. Okay, so again we check with that. If found is equal to minus 1, then we say that element not found in the list. Otherwise, instead of this found is equal to minus 1, we can also write if start is less than end, that also you can write. Then also you can say that the element is not found. Otherwise, you can say that the element is found at so and so location. The element to be searched is found in the found location, because whatever the location the element is found, that is updated in the found variable. Okay, it is always, it will be available in the mid location if at all it is available. Right? So let us compile and execute this. Enter the number of elements in the list, say 10, say 20, 40, 60, 80, 100, 120, 140, 160, 180, 1, 2, 3, 4, 5, 6, 7, 8, 9, 200. Okay. Enter the element to be searched, say 120. Is at fifth location, 0, 1, 2, 3, 4, 5. Okay, so that's it about linear search and binary search. So let us stop here. Thank you.